Hey everybody, this is Larry. This is me going over Q3 of the bi-weekly contest 42 on Leetcode. Maximum binary string after change. So, well, before I say anything, hit the like button, hit the subscribe button, join me on Discord, and ask me questions there or here, wherever you like. But yeah, so for this problem, I spent about almost 10 minutes during the contest, and a lot of it was me trying to validate and prove that the two things that I went through a lot mentally, because writing the code was still tricky as well. But the part one is just proving that the greedy was correct. And that was just me enumerating a couple of cases, a lot of them in my head. But if you watch me solve it live, I actually write it on screen as well. And then two is just implementation, and that was also a little bit tricky. I kind of bounced back mentally about different ways of doing it. Other people people took their time, or at least the top people, like these are the fastest people. That's a little bit tricky. So for greedy, my thing that I was trying to prove or figure out is that, okay, let's say I have these islands of ones. What do I do with them, right? And that was kind of my struggle of trying to figure out, okay, how do I approach this, right? And the way that I proved it is that, okay, well, if there's a prefix of 1, well, you want the lexicographically largest or maximal binary string. So anytime you get a 1 in the beginning, you're done, right? So then we just remove the 1. I mean, I think that part, that greedy, you could prove easily in your head, in your mind, in your heart. But then here is the next part, and then 0 is, okay. And it took me a long time to really visualize this, is that, okay, given this, the first 0, what can we do here, right? Well, so the most optimal thing you can do is always convert the first digit to a 1. So, and given these two operations, I didn't go over it in this explanation, so I should have. But given this, you could look at operation 2 as just moving 1 backwards, right? So given it's 0 and 1, you can move them backwards. You could do it infinite amount of times, so that in theory you can move all the 1s to the back if there was any 0s in the back. So you can do this unlimited time, right? So I think about it as just moving 1 to the back. And then in this operation is that, well, it is what it sounds like. Given 2 zeros, put a 1 in the top, right? So then combine these two operations, I think, well, it makes no sense to move a 0 to the front unless you could create a 1 of them, right? So that means that working a little bit backwards and forwards at the same time, and it's hard. If this is hard to follow, let me know. But yeah, so then now we can just take the next 0, say, and then put it to the front. And we only do this because if there are 2 zeros, then we know that we can put a 1 in one of them in the front, right? So then that's basically the idea here. And because you think these two operations together in this way, and that's the only way to get a more maximal string, then you always have a 1 in the most significant bit where it was previously a 0. So no matter what the suffix is, this is always going to be better. So then now, and of course, as we said before, now we can ignore the string for a second. And as we said before, with a 1 in the beginning, we know we're done, right? So then now, you could do this code maybe with a 2-pointer or something like that. But, and there are a couple of ways to do it. I think you could do it with 2 pointers, for sure, to be honest. But the key thing to not make a silly mistake with this greedy is that n is 10 to the 6, and it's very easy to make a mistake, and I've done this in the past, where you make it n squared by accident with if you're not careful of the indexes. And that's the second part about what I said about implementation, and why I was trying to make sure that I have an O of n, or maybe n log n if I have to. But I was relatively confident that I just have to be careful with linear time solution. Okay, so then now let's go over the actual code a little bit. It's a little bit messy because hopefully once I explain in English, that'll be clearer. So yeah, so if 0 is not in the binary, that means that there are no zeros in the number, then you can just return it, right? And then otherwise, this is just setting the number of n. So this gets me the first 0. What does that mean, right? As we said before, if a string has prefix of 1s, we can just get rid of them, right? So and that's basically what we do here. I have an answer array for all the prefix of int, and you could have probably done this in a slicker way, but I want to be really careful because if I had a string, for example, if I had a string that was like this and I do this, in some languages that actually becomes quadratic, and I always forget whether Python is one of them, because I know that in Java, if you don't use string buffer or something like that, that would be quadratic, right? So I wanted to be really careful, so that's why I did this like weird looking, but should be okay things. So then now what this does is just putting the first putting all the prefix of ones away, and then after that I just count the zeros and ones. And as we said before, because you can kind of do this repeatedly, we just then in that case actually makes the most sense to put all the zeros in the front, and then convert all of them except for the 1 zeros that is left to a 1, right? And that's basically what I do. So every time I was too lazy to simplify this expression. You probably could have if you really want to like make your code look prettier. But for me, I rather my code look exactly how I would describe it in English, which is that, okay, for every 2 zeros I have, I move it to the front, and then for every 2 zeros that are in the front, I add a 1 to the beginning. So basically that's what this code, that's what I want to convey and say, and that's what this code does. And then after that, this is the leftover 0, we append it, and then at the very end, we have all the ones that are left over, and we just put it in the back, and then we just put them together in a string, and that's basically it. In terms of complexity, well, this is going to be O of n time, because we look at each element like a couple of times, but a constant number of times. You could, kind of go through this and see why. And in terms of space, it's going to be O of n, also the lower bound, because, well, that's you cannot do lower space than what you need to return the result. And the result is linear, right? Or required linear space. So yeah, so that's all I have for this problem. You could watch me struggle with this one live, though a lot of it during the contest was me just thinking about it in my head. I did a couple of examples just to kind of help me visualize, but to be honest, I did a lot of visualization in my head. So let me know what you think about this problem. You could watch me solve it live next, and I will see you soon. Okay. This is just greedy, but I have to be correct. And that's kind of it, but that's annoying to get right. What the now? Do you do greedy like that? I wasn't sure about that one, to be honest. Hey, thanks for watching. Thanks for the support. Remember to hit the like button, subscribe, and join me in Discord. Ask me questions. I love questions. Let me know what you think, and I will see you next problem. Bye-bye.